similar and what it means for two triangles to be similar. All right. So can someone tell me what it means for two figures to be similar? What does that mean? In other words, what's the difference between congruence and similarity? Odin.
They have the same shape but not the same size.
Right. Similar means same shape but not the same size. Whereas congruency means same shape and same size. All right. Now, what controls the size of a figure? The length of the sides. All right. The length of the sides control the size. Angles control the shape. So if it's same shape, what does that say about their angles? They're congruent. Good. What is that? But what relationship do the sides have? Because they do have a special relationship. They're just not congruent. They're what? Proportional. Good. All right. Meaning that they all have, if you divided the corresponding sides, they would be the same scale factor. All right. Because remember, similar figures, that goes along with dilations, which we talked back in Unit 1. So even though they're bigger or smaller than the original, they still are the exact same shape. All right, that's why their sides are proportional. Now, how to prove congruent triangles? There are 3 postulates, just like how there were 5 congruency postulates. Can someone name me one? Peyton.
Side, side, side.
Side, side, side. What does that mean?
All sides are equal.
Nope. Not equal. They are what? Proportional. So that's the difference between congruency and similarity. The sides are proportional, not equal. What's another one, Allison? AA. So angle, angle. What does that mean?
That at least 2 sides or 2 angles are congruent, and that means the third angle is also congruent.
Right. So at least 2 angles are congruent. Why we need 2 angles? Because and not instead of 3, because the third angle would automatically be considered congruent if 2 are congruent because of the third angle theorem. All right. What's the last one? Side angle side. What does that mean?
2 sides of the same.
So not the 2 sides aren't the same. They're proportional. So 2 sides are proportional and an angle is congruent. Where does that angle have to be?
In between.
In between the 2 sides. Good. In other words, it's the angle that's formed where the 2 sides intersect.
What was the thing that was like S? It was like a 5-letter thing. It was like S A C B C. Yeah, what was that?
Okay. That stands for corresponding parts of congruent triangles are congruent. That's more so for with proofs. All it means is that once you prove congruent triangles, you can then prove that any corresponding part of those 2 congruent triangles are congruent.
It was like H.
The hypotenuse leg. Yeah. It just means that the hypotenuse and a leg of the right triangle are congruent with the triangle. All right. So today we're talking about side splitter. So like I said, it goes along with a lot of the current picture. It's just one of those theorems that come from similar triangles. All right. So hope you guys are decent with proportions because that's a lot of what today's going to be. All right. Okay. So take out your packet. Go to page 9. I'll check homework at the end of class. Those pages 3 and 4, 7 and 8. Right there. I thought I gave you. Are you sure I didn't give you that one?
Yeah, I can show you what I got the yellow paper and then I got
Now there's a copy of that. Okay, how many do you need packets?
I lost.
Good. Oh, yeah. I found it. You found it.
Yeah, no, I don't know that style.
I just have.
I throw away.
I have all of this in this. No, I didn't even know you had it. Because like, I tried. This hasn't been that bad. That's not budget. I have this trade.
I throw away all the work.
Why is it? Do you remember?
You only work at classes.
Well, I have all of her work.
I know.
Did she stop teaching?
I think she moved.
Definitely.
No, because I've seen her in Walmart. No, I saw this kid in Walmart.
No, we're talking about Miss Blake.
I did a.
I did not say
Yeah, no, I got
this
Dude, I'm like the blindest thing I've ever just.
Like he just think about it. He never
Oh, yeah.
had a school that had to deal with it.
I didn't think about that. Yeah. And then no good.
People like pay.
Didn't you go on that like, that home run with the little school?
Yeah.
We were saying.
That's true. It's the office.
Bro.
No, it's how it's done.
Really? What happened?
It's like.
Personally, yeah, but like, probably through.
Yeah. You get just drop out of this.
Yeah. Next year. You only have like 3 more.
Here, I'll give you the inside.
Why did you think this?
Drop it off.
Right now, you put it down.
Takes like about 30, 40 years. 40 years working at Walmart.
Yeah, right.
Is it better? Is it better than high school?
So those of you who are waiting on packets, you'll just have to wait for like 3 minutes while they're printing off. Where's my pen?
Yeah, no, I do like that.
It's debatable. Yeah, like Walmart for 40 years of this. You're living off of nothing. It's a hard choice. I was at Walmart and I was checking out the guy, the Walmart worker, this guy worked at Walmart. He comes up to the checkout and he has like 5 buttons. He has like a Pepsi and like hummus and chips and like gloves and nothing else.
Hey, Charlie, can you go check to see if I left my pen in the copy room after you finish that?
Yeah, that's why if you work at Walmart.
We only do this, right?
Well, it's printing 5.
Oh. It started beeping, it just like stopped.
It's completely different. He just stole from
I
my
thought that it was done.
Stole like $10.
You'll work at. Oh, yeah, I know you're not.
I gotta say,
What is that thing like,
Actually, that's what's sad.
Guys, what's up? A 48?
Wait, what are we
And they have
doing?
like a 60.
I'm actually, I'm going to it seems like it's under work.
I'm going Mr. Walker tomorrow morning.
Like,
I
you
have
gotta
52 on that test. Or no,
that is absolutely amazing. Absolutely stellar. Carson, you have an absolutely stellar.
Don't do that.
Dude, that's my favorite.
At all. Schizo. Scratching.
I do it I just go.
Because you don't have an eraser. I didn't see that.
Like, I literally.
I know this.
The race, and you're like, oh, shoot, I haven't. It makes me so mad.
I love it. Especially in my
Oh, Gil love this. Allison, doesn't Gil love
It was a
this?
race. Oh, race.
Gil loves
So
It was
He
the best
hates
game of my
it.
life.
he does
No,
love Carson though.
Does
All
anybody
good to talk about.
He just wants to.
Hey,
Yo,
Hey, oh wait, how Peyton likes his arms. Which one? He has 5. Genuinely so.
Haven't been.
Wait, I forgot how to do this.
Okay, hopefully Miss Murphy will not have to say any more bad words. So, working on it. Charlie will come in with them soon. Go. Okay, so if you don't have your packet, just follow along for right now. We're not going to go too far in depth before the packets are done. All right. So, today, side flare theorem. It's on page 9 of your packet. So, it's saying that since we know similar triangles, sometimes if we have lines drawn parallel to a given side, the triangle will divide the other two sides. And that division is actually proportional. So, 9. So, first things first, we got to justify that these two triangles are similar. And by the two triangles, I mean ABC and ADE. By the way, guys, when it comes to these, color helps because it helps you visualize where the triangles are. All right. If you want color, there's some on the shelf if you want to grab some. Now, in order to justify that these are similar, let's kind of weigh our options here. So there's 3 possible postulates we can use. What is the only one that would make no sense? Did it finish or did it keep it?
It made another one.
All right, who else needs a packet? Put your name on the board when Elizabeth comes back. Just give them to me, I'll take them.
Wait, do I just grab one?
Write your name on the board and then wait till.
No, you
I
don't.
guess both of them.
Peyton.
All right, so essentially, what we are doing is we need to figure out which posture will be the easiest to justify with. Now, it's kind of easy to determine which one because are there any sides that they flat out gave us that we can check for proportionality? No. So we're probably going to be showing that these are similar by angle. Now, the way we can do that is because they stated that BC is parallel to DE, which they marked with these little arrows right here. So, based off of what we know about parallel lines, as well as some of the other properties we talked about, what is one set of congruent angles on between the two triangles? Abigail. So ABC and ADE. Good. So ABC is congruent to ADE. Can anyone tell me why? They're corresponding. So they're corresponding angles on parallel lines. Because remember, corresponding angles formed by a transversal on a parallel lines are congruent. It means they're in the same spot. So if you couldn't see that, by all means, extend the parallel lines. You can also extend the transversal sides. All right, someone else. Name me another set. Fisher.
A is like equivalent to itself.
So I would say BAC, which is just angle A, but I'm just doing it for the two triangles, is congruent to DAE. So in other words, it's just the same angle. What property allows us to do that, Allison? Reflexive. Now, since we have two angles, we have enough to prove similarity, but I just want to go ahead and knock out the third angle anyway, because that relationship is important. So that third angle set is ACB is congruent to AED. Who knows why they're corresponding? So just so you're aware, when it comes to triangles that look like this, so a little one within a big one, that's typically the relationship. All right, there's usually two sets of corresponding angles and there's one reflexive property in there. So because of that, we can now concur that triangle ABC is similar to triangle ADE by angle. Now, that was just to show that those two triangles were similar. Now let's get into some stuff that we talked about earlier with the warm-up. All right, so this is just review. So they then said, if AB is 6, AD is 10, AC is 9, they want us to find the length of AE and the length of CE. So first things first, you always start by labeling what you got. AB is 6, AD, so this entire side length is 10. AC is 9, and they want us to find the length of AE. So let's call that X. And then the length of CE, so let's call that Y. Yes.
Wait, so what did we do this by? What did we take 6 and 10? And then we apply the time scale factor. And then take is that what you do?
Essentially. I was more leaning more towards setting up a proportion, but you were on the right track. You could do it by a scale factor. All right. So, like Carson said, you would start by setting up a proportion. So I'm going to do big over small. That's just kind of my go-to. I always do big over small. All right. So 10 over 6. Now, what am I going to set it equal to? What's a set of corresponding sides do I have? x and 9. So it would be x, because that's coming from the big triangle, over 9, because it's coming from the small triangle. You got to keep those proportions consistent. If you did 9 over x, you wouldn't get the correct answer. All right? So corresponding sides have to be together. Same triangle has to be together. All right? So check vertically and horizontally. It needs to be either corresponding same triangle or same triangle corresponding. All right? Now, what do I do now to solve for x? Cross multiply. So I have 6x is equal to 9 times 10. So 9 times 10 is just 90. Then what do? Divide by 6. X is equal to what? 15. So that's also what A is equal to. Now, finding y is going to be really easy because I don't even have to set up a proportion. What's the only thing I got to do? 15 minus 9. So if you look, 15 is the whole, 9 is just a piece of the whole. To find the other piece, you just subtract their lengths. So 15 minus 9, that's equal to 6, which is equal to y, which is equal to CE. That's review. So that was just kind of review stuff we did last week. Nothing new yet. We haven't done side splitter yet. All right. However, side splitter is pretty similar. Still dealing with proportions. You just got to be careful where your corresponding sides are. Now, what they want us to do now is they want us to set up the following ratios. So they want us to do side AB over side BD. So what are those two numbers? So AB 6. What's BD? How'd you get that? Right. BD is the other piece of the whole. We got the whole, which is 10. Another piece, which is 6. 10 minus 6 is 4. So if we do 6 over 4, because we're doing AB over BD, someone besides Riley, what does that simplify down to? 3/2. We're going to go do the same thing on the other side. So AC over CE. So what would my proportion look like? 9 over 6. That simplifies down to what? 3/2. So what do you notice? They're proportional. Which also means they just simplify to the same number. Now, this right here, those proportions that they set up, they didn't just do it for giggles. They did it because that now shows side splitter. All right, so what side splitter actually is that if you have a line drawn parallel to any side of a triangle that intersects the other two sides, it will divide them proportionally. All right, so if you look here, if they give us AB, so this side, and BD, so this side. All right, so we're just taking the two pieces of the sides, making a proportion. If we then do the corresponding on the other side, so AC and CE. So all it's saying is that if we take the two pieces of each side, make a proportion, those two proportions should be equal to each other. Now, given that BC is parallel to DE, we're going to show algebraically that the side splitter theorem works. All right. So, first off, we got to show that these two triangles are similar, which we can use what we did in the very first problem to show that. So I'm not going to beat around the bush. I'm just going to say since angle ABC is congruent to angle ADE because corresponding angles formed by parallel lines are congruent, and triangle BAC is congruent to angle DAE by reflexive property. Then triangle ABC is similar to triangle ADE by angle. So that's the first part, just showing that they are similar. All right, because we can't do anything else with it until we say that they're similar. But since they only told us that the two lines were parallel, we just had to show that they were similar. Now, since we now know that they're similar, we can do all kinds of things with proportions. All right. So, first thing is that I would talk about how AD or AB over AD or AD over AB is going to be equal to AE over AC. So this is where the algebra part comes in. So AD over AB is equal to AE over AC. Now, I can break apart each of these fractions. So in other words, I can rewrite AB in terms of AD. All right. Same thing with AC. I can rewrite in terms of AE. So AD over AD minus BD, that's what AB is equal to. So AB is equal to AD minus BD. All right. So I'm replacing AB with AD minus BD. Actually, I lied. I'm not going to do it over out of AD. I'm going to do it out of AB. Okay, so AD is equal to AB plus BD. So I'm going to replace AD with AB plus BD over AB. All I did was what we call substitution. I wrote out a rule for AD and I replaced it with it. And again, you don't need to know this. We're just proving it algebraically. All right? No. Now, Friday. Now, AE I can write as AC plus CE. This would be AC plus CE all over AC. Now, because this is adding up with two fractions, all right, I can rewrite that as two separate fractions. So I can do AB over AB plus BD over AB, which is equal to, guys, just copy it down. You'll see it in a second. Now, what happens to these two? If you divide anything by itself, it's always 1. So I have 1 plus BD over AB, 1 plus CE over AC. Now, because anything divided by itself is always 1. Because shh, just watch. This is called advanced math. Then I can subtract the 1 to both sides, get rid of it. BD over AB. Did we? No, we started with this.
Yeah, but like, you were up there, not over there. Like, what?
I just don't know.
Already adding, like. Wait, what was the purpose of?
Guys, all we're doing. Okay. All we're doing is proving that if I start with this and work my way around, which, again, it's just deriving the formula. Okay? When we get to quadratics, I'm going to show you how to derive the quadratic formula. And trust me, it's not pretty either. It's not meant to be pretty. It's just showing you where the formula comes from. Okay? Yes.
This is not gonna be on.
The formula is just not this.
Okay.
What's the point?
That. Which you can always flip fractions as long as they are the same flip. So we can flip those fractions. It's not. Okay, guys, listen to me very carefully. This derivation is not on the test. I'm showing you where the formula comes from. All right, it's not just something that someone pulled out of their butt. All right, it actually mathematically makes sense.
No numbers.
Part of it.
So, is 1
Yeah, they would.
over AB.
Guys, I could technically prove that 1 equals 2 if I wanted to. But we're not getting into that.
Can you please do that?
I've done it. I'll do it later.
No, Ron, we need to understand. I want to get it.
Okay, listen. I'll go through this very slowly. So shut up and listen. Okay, so look. Since these triangles are similar, that means I can take the corresponding sides and put them over each other. So I can do AD over AB because those are the corresponding sides. And that's equal to AE over AC because those are the corresponding sides. Now, I need to get it so that it has BD and CE in them. So the way to do that is to replace AD and AE. All right. Now, when we did the warm up today, the way we got this little piece right here is that we subtracted the big minus the piece. But if we add these two, that would give us the big. So that's why I set up this over here. All I'm saying is that if you set AD equal to AB plus BD, I can replace AD with this expression. I can do the same thing with AE, because AE, we can get it by adding up AC and CE. I'm talking about the side length. These are the two pieces of the sides. So all I did was replace AD and AE with these two expressions. So AB plus BD, and I'm going to keep it over AB. Same thing over here. Now, a fraction rule, which you will see a lot in Math 3, by the way, just with rational functions, is that if you have something being added and it's all over a single denominator, you can actually break those two fractions apart as long as it has that same denominator. So I broke it apart into two fractions, AB over AB plus BD over AB. Did the same thing on the other side, said equal to AC over AC plus CE over AC. Now, if you notice, these two is the same thing divided by itself. Anything divided by itself is 1. All right? So I have 1 plus BD over AB is equal to 1 plus CE over AC. Now, since there's a 1 on both sides, I can technically get rid of it and still have balanced equations. So I can subtract the 1 to both sides of gone. That leaves me with BD over AB is equal to CE over AC. Now, as long as you keep things consistent, that means if I flip the fractions over, they would also be equal because of reciprocals. All right, it's like if this was 2 over 1 is equal to 2 over 1, obviously if I flip them over, 1/2 is going to be equal to 1/2. All right, so that's how AB over BD is equal to AC over CE. And this is the side splitter formula. Yes?
Unlike the part below the numbers, since it looks like it's the same thing.
It's not.
It's not. How?
It's
Is it like,
BD and CE are not the same thing as AD and AD.
Well, no, I mean it's the same thing as the one with like 1 plus.
It is.
Did the numbers 31?
The numbers can cancel out because I can subtract 1 to the other side. This becomes 0 for both. They canceled each other out.
But like, I don't get the fish.
You don't have to get it. You just have to write it down.
What is this proof?
This proves the side splitter theorem,
What is
What
this?
is
which
Why
we're about to talk about.
Well, how am I supposed to know what this
Hey,
is?
why is there no numbers
It's
in there?
supposed to
Because it's a prime number.
Shut up.
Guys, this was like half of my college career right here.
Well,
Just writing proofs.
I'm not going to college.
They were fun. Yes. After the lesson. After the lesson. All right, so moving on. Anyway, that was just a roundabout way of saying that this is the side splitting theorem formula. And all it means is that if you take each side piece of the big sides and you write them as a proportion, those two proportions would be equal, just like we got when we did it up here. All right? So, let's do some examples here. Now, this is where those colors will come in handy because we're doing a lot of different triangles. So I got the yellow triangle, which is my smallest, the green triangle, which is my medium, and the blue triangle, which is my biggest. Again, don't worry about the proof. It was just, so in Honors Math 2, I'm required to actually show you how to derive formulas. But you don't actually have to know how to do it. It just comes in handy when you guys get to more advanced math.
Do you have to consider people marking your money?
All right, now, it's saying that all 3 of these sides are parallel to each other. So I'm going to mark them with the arrows. They're all parallel to each other. Thus, RS is 15, VW is 6, TZ is 25, and WZ is 15. And they want us to find ST and UV. So I'm going to go through and mark everything I know and everything I'm trying to find. So RS is 15, VW is 6, TZ is 25, WZ is 15. We're finding ST, so I'll call that X, and UV, which I'll call Y. Now, based off of the side splitter theorem, okay, the easiest way that I can explain the side splitter theorem is that it is all of a small side of the smaller triangle and part of the big. In other words, whatever 2 triangles you're dealing with, all right, you would take all of the small side and then put it over the other part of the big that you didn't use. Uh-huh. So, solving for x is the most useful right now. So how would I set up the proportion for x? So which two triangles are we using first off? What color?
Blue and yellow.
Green and yellow. All right. So we're using the green and the yellow. So we're ignoring the blue right now. So we need all the small. Which one's smaller, green or yellow? Yellow. So I need all of the small. So I'm going to use the side that I already know, which is 15. I'm going to put it over the other part of the green. So on that same side, what's the other part of the green? Guys, on the same side. So all of the small, the other part is the green. So that's 6. You're looking off one side. Now, on the other side, what's all of my small for the other side? 25. And what's the other part of the big? X. And there's your proportion. You guys see it now? You do all. So if you look at one side, so ignore this for a second. You're doing all of the small. You're doing all of the small. All right? Then, whatever you have left of your bigger triangle, that's what goes in your denominator. You do the same thing on the other side. You do all of your small. And whatever's left of your bigger triangle, that's what goes in the denominator. Does that make sense now?
What are we trying to find?
X.
I thought this is like, why does it even?
No, it's like one of those word games. It's like 15 is equivalent to 6, like 25 is equivalent to what?
So. Yes.
We knew how to do this before we incorporated this in, like we could solve something.
You could, but you still got no side splitter. Wait till we get to the stuff tomorrow and Thursday.
This is all.
Yes.
Does like the vertical ones just like not matter in this equation?
No, the vertical lines are just showing that these triangles are all similar because they're parallel. So we get a lot of congruent angles in there because of all the parallel line figures. So if they didn't tell us that these were parallel, then we couldn't do this theorem unless they flat out told us they were already similar. So the parallel lines just let us skip the fact that we need to find that they're similar or not. So if I cross multiply, I get 15x is equal to 25 times 6. What's 25 times 6? 150. Divide by 15. Boys, please stop talking. X is 10. Now, that one was the easy one. Well, the other one isn't hard. You just got to do one extra step. Okay, so now I'm solving for y. So which two triangles do you think is going to be the most useful to solve for y? The green and blue. So, stay crescendo, my darling. Stay crescendo. If you don't know what that means, learn band and chorus. This is what happens when you have two music teachers. All right, so I want all of the small of green. Here's the problem, though. What do I need to do to get all of the green? Add the two pieces that we had for both sides. So all of the green for this side would be 21. All of the green for this side would be 35. So you got to take that into account. Now, we cannot use the yellow triangle to find y because when you do side splitter, all right, we're talking about a triangle being cut into two pieces. All right, the yellow and the blue don't connect without that extra piece from the green. All right, So it has to be the full green and the full blue. Now, set my proportion. What do I got? No.
35
No. 21 over y is equal to 15. We already solved for x, guys.
I did 35 over 21 equals 15 over y.
21 over y, 20 over 15.
You're right.
How did you get that?
I need a calculator.
So, like I said, the funny thing is that the math itself is actually simple. It's just setting it up. All right, so like I said, all of the small over part of the big, and it has to be on the same side. So this first one, all right, so 21 over y. 21 is all of the small triangle. All of that one side of the small triangle. And then we're looking at the same side. We need the only part of the big that's not being used, which is the y. That's why it's 21 over y. Then this one, all the small on this side, so that's 35. And whatever part of the big we have not included yet of that side length, which is 15. Yes.
How do we know what goes over what?
It has to be on the same side. So in other words, if you look at the big triangle, anything that's on this side,
I would have gotten the same thing from the equation. I just like reversed the things because I was doing.
I mean, you could technically do it that way, but it's. Okay, so guys, as long as you keep things consistent, all right, it doesn't matter. Yeah. But if you don't keep things consistent, that's where it goes to crap. All right. So if you cross multiply, you get 35y is equal to what? 315. Divide by 35. Y is equal to 9.
Well, I got 9, and I did it with, wait, what? I did it without doing the adding like the sides. Like I just did 6, wait, hold up, I did 6 over x and then 10 over 15 and I still got 9.
You got lucky.
Yeah, lucky.
10, you got 10.
Oh, this is all.
All right, let's try another one. Okay. Okay. Come on, guys. Come on. All right. So let's do another one. So right triangle AD is partitioned below. The lengths are 2, 3, and 5. AD is 30. And they want us to find AB, BC, and CD. So all of this side is 30. And they want us to find AB, so let's call that X. BC, let's call that Y. CD, let's call that Z. Now, we actually got to use one of the things that we did this earlier today with the warm-up to find one of the sides before we can do side splitter. What do we need to do? Well, I would combine these first. So that's the first part. 30 over 10 is the first part. Now, which triangle am I finding?
6, 9, and 15 respectively.
The small one.
In other words, what variable am I finding? X, Y, or Z? No. X.
X is 6, y is 6.
Now, why am I finding X? Because it's a full triangle. It has a point at the top. All right, so I can use similar triangles for that. So if I set up my proportion, X is corresponding to 30, so that's going to go on top. 2 is corresponding to 10, so that's going to go on the bottom. So, same triangle, corresponding sides. This is not side splitter yet. This is just the stuff that we did for warm-up. Cross multiply, I get 60 is equal to 10x, so x is equal to 6. So x is now 6. Now I can use side splitter and work my way down. So I'm going to find y next. So how can I set my proportion to find y? Nope. 2 over 3 is equal to 6 over y. I did all the small, part of the big, all the small, part of the big. So if I cross multiply, I get 2y is equal to 18, y is equal to 9. Now, I don't even need to do the last one. What can I do to find z? Add 6 and 9, subtract it from 30. So 6 plus 9 is 15, minus 30, 15. All right, so now the opposite or the converse of the side splitter theorem. It's just saying, so in a line or segment divides two sides of a triangle proportionally, then it's parallel to the third side. So basically, originally we start with if two lines are parallel, then the sides that get split by that line is proportional. It's backwards because that's the converse. Proportional means parallel. So we just got to verify first that AB over BC is equal to AD over DE. So 10 over 8, that's AB over BC. What's 10 divided by 8? Or was it simplified down to? 3/2. No, that's 5/4. My bad. All right. 15 over 12, that's AD over DE. What does that simplify down to? Fraction. 5 over 4. So since these are congruent or the same, that means that those two lines are parallel. All right. And then the rest is just kind of more of the same. I'm not going into that. Okay, so. All right. So your homework for tonight is pages, so 11, 12. That's your homework for tonight. Yes, you're still responsible for it. So I'll actually, because I had so many people out on Friday, I'll check Friday's homework tomorrow.
What are they?
Wait,
4,
what?
5, 6, 7.
Friday's homework was pages 3, 4, 7, and 8. It's also in Canvas already. The assignment's already in Canvas.